So let's say this is your up to here the tissue is attached. So up to here the tissue is attached to the bone, and approximately here you have the flexible tissue. So you stop with the flange just here. You don't extend fully in the last fold, in the maximum area, because here the lifting, it may lift the denture. When the patient is eating or chewing, then the denture is lifting.
Jadi untuk gambar ditarik itu yang diarsir adalah bagian mukosa yang menempel di tulang. Nah itu ketika membuat desain nanti tidak boleh melebihi yang bagian yang sebelah kanan yang area mukosanya yang bergerak, sehingga kalau misalnya desainnya melebihi dari di area mukosa yang bergerak, maka ketika pasien itu mengunyah atau misalnya menggigit itu gigi tiruannya bisa terangkat.
This is for the cast partial, for the partial denture. For the full denture, you have to, this junction is very important for the full denture, because this is the seal area where the denture, that makes sure that the denture, especially with the upper denture, is really suction, or when we say suction, this is this area where this tissue is making a sealing, so air is not going under the denture. So this area here. Okay?
Jadi ini sangat perlu diperhatikan, terutama untuk pembuatan misal gigi tiruan lengkap ya, GLL itu maupun GSL, bagian ujungnya tadi itu adalah merupakan seal, jadi dia harus rapat, sehingga untuk misalnya gigi denture pada rangkas itu dia bisa melekat erat gitu, itu vakum nempel.
So as long as possible, but not too long that you don't go cross into the flange. These are the different designs. Now here you see we have anterior missing teeth, basically the class 4, and you see we keep the maximum distance between the rest. So we keep the rest maximum front, and we keep the rest maximum distal, so we get the largest area for the denture for resting, because we have very strong, when the patient bites the front, very strong tilting, so the bite forces now will lift the denture in that direction. So you keep, for stability, you keep the max distance maximum front and maximum distal, so that the denture is stable in this situation as well.
Untuk desain pada gigi kehilangan gigi-gigi anterior itu biasanya resnya itu dibuat selain pada gigi depan itu ditarik sejauh mungkin ke area molar itu, supaya ketika ada tekanan gigitan dari rang atas, maka gigi tersebut
this with the lecturers, with the class. So you have this and you can review. Ideally, you share it with the students so that they also can, one more time, in their free time, look at it, study and understand this whole subject.
Thank you.
Okay, and here we are now going into the planning of the denture. This is the first step, is planning. Now, planning is a very important word when it comes to prosthetic words.
Jadi untuk pembuatan pada desain gigi dengan rangka logam di sini yang pertama adalah planning.
Very often, this is the situation where a problem starts between clinic and the lab. There was not enough planning.
Jadi kita harus memiliki perencanaan yang bagus ketika akan membuat misalnya order dari di lab.
It's like when you say, okay, let's build a house. Then yes, let's build our own house. Then you say, okay, let's buy bricks. And then you buy stones. But you have not planned how many rooms, how many floors, how big the room. You say, yes, let's plan. So with the prosthetic work, it's also, yes, let's make a bridge. But what exactly do we need to make a bridge? What is the function? What is the patient situation, the requirement? That in dentistry, very often, we see a weak part in planning, whether implants, cast partial, full denture. Very often, the planning is not taken care.
Kita harus memperhatikan perencanaan dalam kita setiap membuat gigi tiruan. Desainnya bagaimana, lalu kebutuhan pasiennya yang bagaimana, itu harus diperhatikan.
So this is normally where the work is starting. Very similar models I saw in the morning. So the model already has to have a few requirements. We have some requirements to the model. From where does the model come? The model, how do you make the model? Are you making the model? No? The dentist is sending you the model? Yes. Oh no. Those are the worst models. Because the dentist, do you think the dentist has a vacuum mixer in the clinic? You know what is a vacuum mixer? Who knows what is a vacuum mixer? Raise hands. Who has worked with a vacuum mixer? Yeah, like that. Yes. Yes. The one bowl, and then you make the water plaster ratio. Then you mix it, vacuum. What is the use of vacuum mixer? Why should we use a vacuum mixer?
The order not using the vacuum. Not using the vacuum.
You're not using the vacuum.
And sometimes the order is
okay, I will speak with the dean. A lot of investment, we have to buy some equipment. But okay, you're not using, but at least you should, if you know why you should use a vacuum. Only then you will decide to buy a vacuum mixer. So first we need to discuss, why should we use a vacuum mixer?
Kenapa kita harus memakai vakum daripada
Any idea what is the benefit? He knows? Huh? No bubble, no air bubble. Yes, there is no air bubble. So, and then if there is no air bubble, the model is more hard and you don't have the surface. The surface is fully smooth. If there is air bubbles, then you have the roughness. If you have the roughness, then you make the waxing, then the surface also have the roughness. And then you have more work for finishing. You have to again make the area smooth. If roughness on the model, then you have roughness on the metal frame. Then you have to clean the metal frame, you have to trim. If you don't trim the metal frame, the patient has a big problem. Very painful. Get inflammation, ulcers, big problem. So, it is a must for good quality to use a vacuum mixer. Now at least you know why. Correct? Always the story starts, this is dental technology. So you can ask everything what I say, you can ask why. If I say you should do like this, there is a reason why we do like this. Anything you can ask, okay Tarek, why? If I say you need to use a vacuum mixer, you can say, okay, why? If I say you need a debubblizer, why to use spray on impression? Then you can ask, okay, why? Why you make the design like this? Why you make the clasp design like this and not like this? There is a reason. Every little detail that we do in our procedure has a reason. And there is a very valid question, why do you do like this? And then I'm able to tell you, if you do like this, you will have this and this benefit.
Jadi untuk pembuatan frame ini, kalau bisa menggunakan vacuum mixer itu agar udara tidak terjebak sehingga nanti hasil cetakan model tersebut itu halus. Sehingga ketika model cetakan tersebut halus, saat kita membuat castingnya itu nanti selesainya itu finishingnya lebih sedikit yang kita lakukan, dan kalau misalnya finishingnya kita nggak melakukan dengan baik, maka ketika dipasang ke pasien maka akan sakit gitu mukosanya, bisa menyebabkan inflamasi juga. Jadi dalam setiap pembuatan dental produk ya yang dilakukan oleh dental technician itu, kita harus menanyakan kenapa kira-kira kita melakukan hal tersebut gitu.
So we have very different plasters, die-stone. So some are called plaster of Paris, die-stone. They have all different properties. Class 3, Class 2 plaster, Class 3 plaster, Class 4 plaster. Have you heard of different plasters? What is the difference?
Strength.
Yes, the hardness. Number one. Yes, very good. What other differences?
fungsinya atau apa? Fungsi berarti function.
Function? There is something like expansion. Expansion, the plaster has an expansion. So that also, what is expansion? What does it mean, expansion? Who can tell me what is plaster expansion?
Mungkin ada yang bisa menjelaskan ekspansi
Ekspansi pada gipsnya.
ya.
Yang keras dong.
Ya, siapa? Mungkin yang belakang
Juga
ekspansi itu
apa?
Okay, I can help you. Expansion means if you make this plaster, you mix dry plaster, dye stone, with water, you mix, and when this plaster is becoming hard, we call it setting. When the plaster is setting, there is something like a setting expansion. It gets a little bit bigger. So different plasters have different expansion. And that is a big story for us technicians. Why? Because expansion how do we make crowns, cast partial? Everything starts, whatever we do, we build it on this dye stone. Correct? We do waxing on this dye stone. So this dye stone should be exactly the same like the patient tooth. The more precise the impression, it starts with the impression. So this information of dimension, of size, the patient record starts with a good impression.
Jadi saya jelaskan kalau ekspansi tadi, kenapa ekspansi itu penting dan pada tipe-tipe gips itu memiliki ekspansi yang berbeda. Jadi ketika pencampuran gipsum itu terdapat setting. Ya. Jadi setelah setting itu apakah ekspansi antar gips tersebut itu berbeda gitu antara gips satu dan yang lainnya. Lalu selanjutnya untuk pembuatan crown ya. Untuk pembuatan misalnya seperti crown itu yang paling penting itu adalah cetakannya. Jadi cetakan yang baik sehingga nanti mendapatkan detail dari pasien itu dengan baik. Mungkin ada yang bertanya.
Okay, so the impression, is the impression important? Is the impression important? Yes. Why? Because it gives us the exact information, dimension, size of the patient's properties, tooth, gums, arch, all this. So the all starts with a good impression. And you cannot imagine how many fights I had with the dentist about the impression. I said, dentist, sorry dentist, this I cannot work. The dentist said, hey, I'm dentist, I study university. You dental technician, you tell me my impression not good? I say, yes, sorry. But doctor, impression not good. You make my work. I say, if I make your work, I can do. But the work will not fit in the mouth. I can do anything. I am a technician. But afterwards you have problem. The patient look in your eyes, not in my eyes. I am in the lab. I no problem. But if the work is not fitting and the patient has pain, then the patient look, doctor, not good. So I want to help you. I'm your helper. I work for you. I get money only because of you. I can have food at home because of you. I need you. So that's why you are very important to me, technician. Please make one good impression. And I can tell you what is good impression. Why I talk 2-3 minutes about this, this is so important. You, technician, should be able to tell the dentist, doctor, if we do like this, we can get good result.
Jadi kita sebagai teknisi itu harus berkomunikasi dengan dokter gigi dengan baik. Kalau misalnya dikirimkan mungkin ya cetakannya itu kurang bagus, mungkin kita bisa berkomunikasikan bahwa nanti kalau misalnya kita tetap mengerjakan yang cetakan tersebut yang kurang bagus itu maka akan mempengaruhi hasil, sehingga itu akan berdampak juga kembali lagi ke dokter gigi dan akan dirasakan pasien bahwa produk yang dibuat oleh kita tadi tidak bagus.
The best dentist is no use if a very bad technician. The dentist and the technician is team. Both are good, the work is good. The best technician in the world with a not so good dentist cannot perform. The other way also. I give the example with badminton. If you play badminton, if Lucy is a good badminton player, champion, Olympic, I don't know how to play. Then we say, come Lucy, let's play. Lucy, I don't play. I make tang, the ball goes this side. Then Lucy, look, hey, here I am here, play here. Olympic, best in the world. But if I cannot play, she cannot play. Right? But she's Olympic. You understand? So, the dental technician and the dentist both need to play proper. If only one plays good, the other one still will lose if it does not know the work. So it starts with a good impression, dimension, precision, technology. So the expansion, let's say this is your, now let's to make it easy, this is your tooth, okay? You want to make a crown. That means you make the wax coping. All of you know what is a coping? You make a wax coping. So this is stone, stone model. You make the waxing on the model, the coping on the model. If this stone is a little bit bigger or wrong shape, you will make your coping like this. If this is bigger, a little bit bigger than the tooth in the mouth, then your coping is bigger. If this is smaller, your coping is smaller. If the diastone is a little bigger, expansion, no, we spoke about expansion. If the model is a little bigger, the model is a little smaller, your framework is too loose or your framework is too tight, your framework will not sit. So that's why vacuum mixing, model is very important. For me, in everywhere where I work, I gave very highest respect to the model people, to the people who make the model. If you go to a lab, the plaster department, no training. Plaster department is like the dirty room. No qualified technician like to work plaster department because pay is no good. But if you make ceramic, oh, you're champion. But if you say I work plaster department, no respect. But a plaster department is the most important department. If this model is not correct, the best ceramist, no use. The work is not fitting. It can look beautiful, but it does not fit in the mouth. So for me, the technician in the plaster department was the same important than the ceramist or the waxing or the metal technician. Everybody needs to be good, that afterwards your work is good. You understand? So even a plaster technician need to know why the model must be smooth, why the water and the plaster, there is a ratio. How many ml water and how many gram plaster? You say 100 gram and how many ml? Who said? I heard something. 20? 30? Depending to what plaster. Class 3, class 4. It's written on the packet. A good quality plaster company, it's written, let's say for a diastone, normally it is 20 to 22 ml for 100 gram. This is important. If you don't follow this, then the expansion, you interfere into the expansion. It can be more or it can be less with controlling how much water and plaster. So you need a scale, you need a weighing machine, you need a water cylinder to measure how many ml. Who is doing this? And then you are surprised that the work is not fitting in the mouth. It's fitting perfect on the model. You say, doctor, it fit very good. Doctor says, okay, but in the mouth it's not fitting. You say, why? I made everything I made correct. It's perfect on the model. But it's not fitting in the mouth. Because maybe you took a weighing machine, a scale, and you measure the water powder ratio. The same story comes with the investing when you do the refractory. So precision starts here. Many say Germany, Swiss got very good technicians. Yes, but they just understood that it's important to make this simple step, to measure the water and measure the plaster and make today, tomorrow, next week, next year, always follow every case, follow simple things, not only one time. Not only if the professor comes and watches what you do, say, okay, I make proper procedure. Every case, you do proper procedure. Every case, you have to measure water-powder ratio. So for me, maybe I don't finish my class till 12 o'clock. But at least I was able to teach you step by step the very important thing. Then you at least understood this thing. What is the use if I show you the whole CPD story and you go out and your work is not fitting because you have not understood the importance of the plaster? So maybe I come again. If you say okay, then I come again. Thank you. Okay, so let's go slowly, but whatever you learn, you should really understand why we do this step and this step, rather than we'll fast make the class and then you say, okay, but what's the use? Okay, so now you understood expansion, the dimension of the model, roughness, vacuum mixing. Now you know vacuum mixing, why vacuum mixing is important? Yes. What else is important with a model? Yes. And the water that you use is important, because the water that comes from the pipe, from the municipality, that water is not clear water. They put chemicals inside so that we can drink it and don't get sick. There is some chemicals inside. Sometimes the water has minerals. Depends on mountain water, sea water, got salt, different water. So if you have a water with salt, then again your quality is not correct. The model is soft, or maybe expansion not proper. The plaster is not setting. Plaster is chemical reaction. So what water is the best water to make a good model? Distilled water. You know distilled water? Distillized, distillized water. It's basically steam, and then when you collect the steam, it's mineral free. There are no minerals in the water. Then you can be sure that your model is good. So please understand that the model is very, very, very important. Pay respect to a good model. And when you pour the model, have you heard about a vibrator? Huh? When you pour, you have one. Very good. Because you need so that the plaster is flowing. If you don't have a vibrator, then you have to make the plaster more liquid. Then again, your model is too soft. If you follow this ratio, the plaster is a little bit more thick and then it does not flow into the impression. But it's correct. The thickness, it must be a little bit more solid. That is correct. But of course, then you also have to use a vibration so that the plaster is really flowing into your impression. So I can already tell people who don't have a vibrator, they will definitely use more water so that the liquid is more like a soup, the plaster, so that it flows. How did I start this topic about the plaster? I asked one question. You remember? Who remembers how we started this topic? I asked you, who is doing the model? You remember? I asked you, who is doing the model? Are you pouring the model? Or is the clinic sending you the model? Then you told me the clinic is sending the model. And I said, oh no. Because they don't use vacuum mixer, the chair assistant does not know anything about water powder ratio. They don't use a scale to weigh the plaster. They don't maybe use milliliter, how much water, and who knows if they're using a vibrator, all these things. So if the model is not good, then the whole story does not work out. These are the little things we need to all know, that the work will fit afterwards in the mouth. So planning. Then we'll plan the saddle area. This carving, I personally think is not required. The story of this carving got confused. This carving makes sense if you work with acrylic, with dentures. And why did we technicians start this carving? Any idea why we technicians started this carving on the model? So I told you, dental technique. If I say we do a carving, then you should say, okay, why carving? We don't do anything just like this.
Jadi pada pembuatan gigi tujuan dilakukan carving pada model persalinan. Kira-kira apa tujuan carving tersebut?
Why carving?
Biasanya untuk akrilik, kalau misalnya metalkan tidak menggunakan carving.
I can help you. The reason is the material that we are making the prosthesis of. This carving has started with dentures. The background to carving is dentures. What material we make dentures? Yes. If acrylic is setting, it becomes hard. First it is soft, then it polymerizes, chemical reaction, and then it becomes hard. Does the acrylic expand or does the acrylic shrink when it sets? You said it, yes. It shrinks. It shrinks. Acrylic shrinks. So, since the acrylic shrinks a little bit, then on the model it will be a gap. And if on the model a gap, then also in the patient mouth a gap. So if there is a gap, air goes below the denture, and then the denture will not sit. The denture will fall. This is very interesting. How, see, if gravity, no? Gravity, you know what is gravity? Yes? So if I let this fall, this will fall, okay? So if I put a denture, no, I just wanted to show gravity without breaking my pointer. So if I put the denture up, upper denture, lower denture, okay, gravity, lower denture will sit. Upper denture actually should fall. How does the denture stay up without falling? Retention. How? If retention, that means retention means this is retention, grabbing. It would be painful. So retention, no. How does this denture stay up? Yeah, we use the term retention, but actually in terms of physics, it's not retention. How does the denture stay up and does not fall?
Jadi dalam pembuatan denture biasanya dari bahan akrilik itu dilakukan carving tadi karena bahan akrilik itu bisa jadi itu untuk jaga terjadinya pengkeretan di sekitar ya, shrinkage ya. Lalu ini dapat diaplikasikan bisa di rang atas karena biasanya kalau ada denture rang atas itu kalau ada kayak gravitasi itu pasti dia lebih gampang untuk misalnya jatuh kalau denture-nya tidak bagus. Itu kira-kira denture pada rang atas tadi kenapa bisa melekat erat gitu di rang atas dan tidak jatuh karena efek gravitasi kira-kira.
I heard maybe vacuum.
Yeah, good. They discuss.
Louder.
So always ask your teacher why.
Why?
The teacher should be able to tell you why. You know, one of my favorite teacher, it became my favorite teacher because that teacher told me there are no stupid questions. My teacher, my favorite teacher, it became my favorite teacher because of this sentence. There are no stupid questions. There are only stupid answers. So don't worry to ask a question. Nobody should tell you, oh, this is a stupid question. That answer is stupid. If I tell you that's a stupid question, so I'm answering, then that answer to say it's a stupid question already is a stupid answer. So, suction. But how suction? Suction means, but what is? Suction happens, it's some sort of a vacuum. So now my hands, I press my hands together You heard? Hold it.
No sound.
It makes.
Nah.
So, first, all the air is out. If all the air is out, there is atmosphere. No, now there is a pressure on us. Atmospheric pressure. Right now, as we are here, there is also a pressure on us. The air pressures on us. That is what we call atmosphere. Only since it is happening all the time, we don't think about it. But right now, in this room, there is already an atmospheric pressure. So, if there is no air between two surfaces, that means there is a pressure here outside and a pressure here. There is a pressure. If there is air in between, the air presses like this. But if we remove the air, then there is only pressure from outside. That means the denture is suctioning, because once the patient is putting denture, the surface of the denture and the gum is so touching that there is no air between the denture and the gum. Then there is only the atmosphere that keeps the denture up. As soon as air goes below the denture will fall. That's why the seal, what the first said, we said the flange of the denture needs to really be like a valve. No air goes under the denture. As soon as air goes under the denture, this suction will stop.
Jadi pada denture itu terdapat atmospheric pressure, sehingga dengan desain seal yang bagus nanti diharapkan ketika gigi tiruan itu dipasang ke pasien, pada permukaan yang menyentuh palatum itu tidak ada udara yang terjebak di situ, sehingga dia akan melekat dengan erat.
Okay. We need to survey. Now we have clasp. We want that this cast partial denture will sit on the model, and the clasp is making retention. Now we need retention. The clasp goes in the undercut and holds the denture. And if the patient removes the denture, the clasp has to overcome the undercut area and remove.
Jadi pada perencanaan pembuatan clasp pada gigi tiruan biasanya dilakukan seperti ini. Kalau nanti tempatnya itu pada area yang undercut itu, sehingga nanti gigi tersebut dapat duduk dengan baik, dipegangi oleh clasp tersebut.
So we have to put the model in this surveyor. There is one table, we fix the model, and then if we turn this way or that way, we'll create undercut. So now there is no undercut, and if I turn it, now there is full undercut. The surface, no? You make it like that. Now there is no undercut. Now there is full undercut. It's not touching. If I turn the model this way, no undercut. Okay, so we have to find, this is called the path of insertion, the right path of insertion, how the denture will sit, and we have to plan how much undercut? Because too much undercut is every time the patient take out the denture, it will pull the tooth. It will actually extract the tooth. Every time the patient puts in the denture, it will press the denture, and every time it will take out the denture, it will pull the tooth. So it's like an extraction machine. It's like an extractor, this denture that we make if we don't plan it properly.
Jadi pada tahap planning ini ya dilakukan survei untuk mendapatkan undercut. Dalam menentukan undercut kita tidak boleh terlalu berlebihan karena dalam survei ini kan menentukan arah insersi dan lepasnya gigi tiruan tersebut. Kalau misalnya undercutnya itu terlalu besar, maka dia dapat menarik gigi asli juga.
So this is a very, very important part of this whole process, that we plan the undercut and plan it for, there is not only one tooth, there are many teeth. So if I go this way, one side I have undercut, the other side I don't have. So we have to play with the model so that finally I have a position. And once I have the position, we'll mark the position, and then we have to block all the areas where we don't want undercut. If I don't block here, then the metal will go that area, and then I have to trim much more. So if you want easy process, then you block the undercut, you block the area, you do the waxing. This is what we do in the second. You see all this pink that is blocked. This is the undercut area. So we plan exactly the clasp. Here no undercut, and only the clasp tip, 1/3 of the clasp tip goes in the undercut area. So we plan all this like that before duplication. Then the duplication process. This is silicone. Are you using silicone or are you using agar-agar? Agar-agar. Then once you have duplicated, there is a debubbleizer for the silicone material, the investment material, again the weight and the liquid, the measurement is very important. The mixing time is important. Here you've got your refractory, then you have to let the refractory set. Then you dry the model again. Now this refractory again has an expansion. Why do we need expansion here? Any idea? Why this refractory model we are using has an expansion? Or why the expansion here is important? Because physics, metal, when you heat metal, it expands. And when the metal cools, becomes solid, it shrinks. And different alloys have different expansion and shrinkage. Now this cast partial alloy, to have the feather spring hardness that it does not break, it has more shrinkage than the crown and bridge alloy. The crown and bridge alloy has a different property, has a different shrinkage property. We have to plan the investment differently. Because this CPD is shrinking, That's why we first have to, with a refractory model, get a little bit bigger. So after shrinking, it's again the correct size in the mouth or in the model. So this expansion and shrinkage, we really need to understand our material and how to control it so that we get our perfect fitting.
Jadi yang pertama itu tentang survei tadi ya. Jadi ketika survei tadi digerakkan supaya kita mendapatkan undercut, mungkin ada satu gigi yang dapat, tapi ada satu gigi yang enggak. Nah, maka dari itu benar-benar harus mengenai semua gigi yang akan dipasangkan. Lalu setelah itu dilakukan block out pada daerah-daerah yang daerah-daerah yang tidak kita inginkan untuk didapatkan undercutnya. Lalu dilanjutkan oleh pencetakan untuk mendapatkan model refraktori dengan menggunakan agar. Kalau di sini itu nanti akan dapat untuk model refraktori biasanya dibuat lebih besar daripada aslinya karena tergantung dari bahan-bahan yang akan kita gunakan. Contohnya pada metal frame itu setiap alloy atau metal ini nanti memiliki sifat fisiknya, jadi dia bisa memuai atau menyusut gitu. Jadi supaya mendapatkan hasil yang bagus, maka kita harus mengetahui bahan-bahan apa saja yang akan kita gunakan dan sifat-sifat pemuaiannya tadi.
So here is like how much undercut with this surveying tools and with this block out. You control how much undercut you'll do, and you mark where you want the glass tip. Everything below this line, everything here is undercut, so you have to only want the glass tip in the undercut, and you have to move your wax arm accordingly. So here you see, you plan your wax arm and only 1/3 goes into the undercut area. Everything else is the arming of the tooth. There is no undercut area. And you see here, you control. This is 0.35. Now you understand this design of this. See how much undercut? These tools, now you see why this design, because this will touch the tooth. This area will be your undercut area. So there are different undercuts. You can say, okay, 0.25. For the molar, you want more undercut, or if you want very strong undercut. This tool and this design is helping you how you can measure the undercut. If this is bigger, then there will be more retention, more undercut area. Then you put your wax glue and you start the waxing, proper procedure, and this we'll do in the practical part when we do the waxing. All this till now was the planning, and now we go to the waxing and finally the sprueing. Now I myself, when I was less experienced, I thought the more sprue, the better. I put one sprue here, metal should flow. I use many sprues, but actually too many sprues is also a problem. This is the casting. And the finishing. This is with the agar-agar duplication. The different wax profiles. And when you have done a proper work, then all will look very fine. Now I just show you at the end something about the different spruings. We have also a troubleshoot, what tells you like what problem investment material sets too quickly, then what could be the possible cause and what could be the remedy. This also I will share with you. It's all on our website available. So this is basically a troubleshooting. Bubbles form in the mixed investment material. What could be the cause and how to avoid it. And for the spruing here, what type of design and what spruing you can use. You see this whole plate has only 2 supply sprues. And here it says what is the wax diameter, 3.5 millimeter. For this type of design, 4 millimeter. How to attach the sprues for what type of framework.
Jadi nanti kita akan dibagikan mengenai cara spruing di metal frame ya. Di situ ada macam-macam diameter yang diameter sprunya juga nanti tergantung dari jenis kasusnya. Lalu nanti akan dibagikan juga materi mengenai problem-problem yang dapat ditemui di dalam teknik pembuatan gigi tiruan kerangka logam. Nanti ada cara-cara penyelesaian juga.
Okay, any questions to this point? Who of you already is doing cast partial? Anybody of you already is doing cast partial?
Apakah sudah ada yang pernah melakukan casting kerangka logam? No, not yet.
Then what are you doing till now?
In this semester 5, we have many steps of practicum because this is a new
batch.
New batch. So the student is not yet approached the spruing and casting.
Only theory?
No.
We do. But this is the early semester.
Yes.
Our year, so they just start making refractory models.
They make the pouring of the refractory models.
After that, they start.
Okay, so all of you are pouring refractory models?
Yes, we make refractory models.
Okay. When you do refractory models, are you measuring the liquid? Yes? With this plastic cylinders? How with that? With the agar-agar?
Yes.
How often can you reuse agar-agar? Three times. How do you know how many times you have recycled your agar-agar? You see, I have very interesting questions. And I ask these questions because they are very interesting. They are very important for you because now I don't know which company agar-agar you're using, but what I know is depending to the quality of the agar-agar, depending to what company, there is a limitation how often you can reuse agar-agar. So you cannot again put some new material, then you have old material. How do you control this? So, how do you control this? Who decides when to put new material, when to discard the old material? How?
Because this is because the student is using the agar for learning purpose.
Yes.
And it does not from the patient and for effectivity of the course in our program
Yes.
study. So we use it many times.
Yes.
But in every semester we usually supply the new one. So it's not from the older no, but perhaps we use it many times to one semester.
Okay, makes sense, I understand. But still, you need a protocol to control at any stage the agar-agar. Because, let me find out, question. So you're now learning how to pour refractory. How do you know that your refractory pouring is good or not good? How do you judge it? What are the criteria that after now you're pouring, okay? Let's say now I'm pouring the first time. Some of you pour many times. Do you think if I pour the first time, it will be as good as somebody that already is pouring for 1 year? No. Okay. Why? What will be good and what will not good? What is the difference?
I think the tails of the models.
The what?
Kalau akhirnya pakai pola balik itu kan nanti sering airnya iya, maksudnya detailnya. I think the details,
The details.
hasilnya itu nggak tajam gitu loh.
Iya, akurat.
The accuracy of the model.
How do you measure it? How do you know it's accurate or it's not accurate? It's easy. You can say it's accurate and doc will come and say, no, it's not accurate. Based on what? You say it's accurate and she says it's not accurate. Accuracy is measurable. Accuracy is measurable. You accurate means what? With the eye or with microscope? Accurate to what extent? What is accuracy? Accuracy only is a term. But in physics, accuracy is measurable. It's accuracy to 1 centimeter precision, its accuracy to up to 1 millimeter precise, its accuracy up to 1 micron deviation. How much accuracy? So accuracy is just a term. So you pour it, but you cannot tell if it's accurate or not accurate. You only can tell there are bubbles or there are no bubbles. Right? Are you using this model? So now you're pouring. You have a refractory. What do you do with this refractory? Are you using it? For what? To make a cast partial? Okay. Now it becomes dangerous. This cast partial is going to a patient?
No.
What do you do with the cast partial? Okay, then you make wax pattern,
Yes, we make wax pattern.
and then after wax pattern you throw.
No. We
Casting also?
Yes.
Okay, very good. Now it becomes exciting. And after casting, you expect it will fit on the model?
Yes.
But not fitting. And then, what is the problem? Why not fitting? So how you can train pouring? You can learn in one day, I think. Morning till evening, how to pour refractory, you can learn in one day. You don't need to practice this for half semester. So then wax pattern, yes, you need some skills, but it is like cooking, but you never taste your food. You only cook, but you never taste it. So you make refractory, you make waxing, you make casting, but it will not fit. Then you carry on. Will you learn? What will you learn? If it's not fitting, that means actually 0 points. So you make again 0 points, make again 0 points, make again 0 points, and then you finish. Do you think afterwards you will be able to do a work that will fit? Chances are very little. So the question should be, how can we solve this challenge? Yes, I fully understand there is an economical part that we have to address. We have to see there are limited resources. How can we utilize these resources in a way that we still benefit from it? Because now, even you don't get result, but still you have cost. The refractory also cost. The metal also cost. Every material already cost. But you don't get result. And you cannot validate the result. So then we would need to think, is there a possibility how we can improve with the limited resources, get more out of it, get something else out of it. But that is a different subject. So I was asking what you are learning. So basically in this 5th semester, from refractory, making refractory model, the wax pattern, and then the casting. Then finishing? Yes.
the type of order. One is like a dummy order, and the second is actual order. So in this
The seniors
this
make the actual order.
yeah, we get the actual actual order from the RSKM, the hospital, and some internship in the internship program. So the dummy order we do it in the lab first in early semester.
Interesting.
But I think your suggestion is good to develop our problem study.
Yes, yeah, because just now I'm thinking when I learned, I also learned in the lab. But of course, there is no dummy work. That means I had a senior, so I make my work and I show it. First the senior shows me how to do, then I do that step and then I show. He says, okay, yes, no, no, no. And then I'll go to the actual. So always is real time with the help of a supervisor, with a senior. So maybe we would need to look into how can this process happen, the training, the steps. So basically all the works would be actual work. Then if it's all actual work, then the economical part, commercial part would support to also process the material properly. But now back to the aga-aga, and for the future, how you would do is, so you will use, you start, the first time is new material, okay? Let's go back. Let's say from tomorrow, we start a new idea. So you will have only new material. You read, I hope you buy Dentaurum only.
We hope so.
Because you can reuse many times. It's a little more costly, but you can reuse it more often. So don't forget, like maybe one material is half the cost, but you only can reuse it 7 times. Our material maybe is double the cost, but you can reuse it 20 times. Which material is cheaper? Finally, yes, buying, first you think it's costlier, but the quality is better. So on long run, it's actually cheaper. And please keep this example, this you will have many times in your profession. You think you buy the cheaper, but actually you're losing money later because you have rework time, you have longer working time. That is not, working time also is money. You have to pay somebody to work. So if your working time is longer, you have more correction and repetition, that is money. So you're losing money, what you saved first for buying something maybe 30% less, but later you maybe lose double. Many technicians are not trained on thinking like this. But it's very important in this modern world to also always think about the commercial part. Is it really cheaper if you repeat the work more? If you have longer working time, then it may not be cheaper at all. Back to aga-aga. First time, new material. Now you already pour it, then it gets solid. Correct? Now you put it into one empty can. So now you know this can is used one time. So you collect this. all this is one time. 1 mole, 2, 3, 4, 5. Once you take now this whole thing and you melt it again, now you know this whole cycle is one time reuse. Now you melt it again. Now this batch again goes into the bin. Now it's the second time. You melt it again, you cut it, melt it. This, what you use, you know it's the third time. You need to have a system. Then you know, okay, this is one circulation. First time, second time, and then you say, 15 times, lifetime over, remove. Else you never control. If every time some is new material, you fill up with new material, then you take 1, 2 old piece, then you don't have control. How old, how new, what is the material inside? Some is very old, some is new, and you don't get your results. You don't know where the problem is coming from.
Jadi untuk pembuatan model refraktori sebaiknya memang agarnya baru ya. Dan kalau misalnya ini memilih bahan yang mungkin bisa digunakan berkali-kali, jadi itu lebih cost efektif. Walaupun misalnya pembelian awalnya mahal atau mahal gitu ya, pilih di showroom ya. Lalu selanjutnya untuk ketika kita menggunakan agar kembali itu sebenarnya kita harus tahu berapa kali kita menggunakan agar tersebut. Jadi dari misalnya membuat model refraktori, terus agar itu dipotong-potong lagi, dilelehkan lagi, dipakai lagi, sampai lifetime si bahan tersebut itu sudah habis gitu. Karena nanti akan mempengaruhi hasil ya.
Jadi jangan mencampur yang lama dulu ya, baik yang lama dibuat berpakai.
You know why the Taurum also is a little bit higher charge? You know why the Taurum is a little bit, price is a little high? Because my boss has to buy my ticket to send me to meet you.
Sir, actually we use agar-agar from the ground.
I know, that's why I'm here.
Okay. How many times actually it can be used, reused?
It is written on the instruction for use. Now we would need to look which one you're using, Duplitop? Duplitop? Dupliform? Okay, before I say something wrong, I one time look to give you the exact, because it's written like 50, if I'm not wrong, it's around 15 times, 12 to 15 times. I one time check, so later I'll tell you the exact. It's written, I think it's around 12 to 15, if I remember right, many years ago when I still was using it, myself as a technician. Okay, any other questions?
Ada pertanyaan jadi yang tadi malam sudah persiapkan, mungkin ayo silakan. Ayo, nggak ditanya. Nggak ada yang mau tanya? Oke. Alright, I think in a forum for lecture today, maybe
Okay.
yeah, we have to take a break.
Here. 25 times.
25.
Will you talk?
Wow.
No. That is not concentrate. Dupliform, no? Ah, that's the same. Concentrated. The concentrated is same. So 15 times. Your question? So, but this again is interesting. See, like somebody may select this material because say, okay, duplicat, dupliform, duplitop. Then you say, duplitop is the costliest, correct? But duplitop you can reuse for 25 times, no? You see the price, duplitop is the highest from precision. Next is duplicat. There is 20 times. Now we saw 15 times dupliform. So the price goes down, the quality so-called goes down. That means because of the quality is a little bit less, the price is less, but you also cannot reuse it so often. So quality, and that is really life has taught me over many years, every quality comes at a price. So whenever we try to save on the price, unfortunately, also the quality is less. That is, life is like that. So always keep in mind, can you compromise on the quality? Is it really a saving to compromise on the quality or not? That is the big question. Sometimes if it's not required to have the high quality, then yes, then you can compromise on the price. If you say, I expect this quality, then my budget is that. But already, and let me tell you that if your university is using Dentaurum, that not only is a statement of we are happy, it is a statement that the management is interested in quality teaching, in quality material. So you can be very happy and proud that you are studying in this organization where already they're thinking quality. So quality is not only material. Quality is a philosophy that you say, we are interested to teach and provide to our students, to our alumni, a good quality so that when they come out of this organization, they already are improving and contributing a better quality treatment to the society and population. And that is an applause for the management. Very good. Okay, fine. Then we'll wrap up at this stage. Thank you very much. And I'm not sure who of you will be part of the practical. Some of you maybe. Who will be part of the practical?
There are 8 people.
8 people from this group. Super. All of those, I'm looking forward to see you afterwards. Those who I won't see, all the best. Enjoy the profession and hopefully see you next time. Thank you.
Before we take a break, maybe we
Yes. Yes.
foto bersama ya.
In the middle. Maybe like this. Let's say here.
Berdiri. Nggak kelihatan kan? Oh ya.
Dia semua kena. 1, 2, 3. 1, 2, 3. Video.
Pakai glory dikit lagi. Pakai itu. Unair. Hebat. TKG. Glory TKG.
Aku pengen ke toilet.
Oh iya.
Kenapa aku pengen ke toilet?
Oh ya, di next time.
Isomatis enggak maksud saya posting di sini. Oh, nanti di atas posting kita kembali ke ruangan aja. Untuk adik-adik nanti setelah ini kan isoma ya, lalu untuk yang sudah dipilih nanti ke perwakilannya ke semester 5, terus yang lainnya di semester 1 ya, untuk melanjutkan lab. Ya, jadi nggak bisa semua karena keterbatasan ruangan. Sampai jam 1.